Well, welcome to lesson 2. We're going to break this lesson into 2 parts. This is the first of 2 parts on properties of parallelograms. And in this section, we are going to learn specifically about parallelograms and some of the relationships of their sides and their angles. So first of all, we need to define what a parallelogram is. And a parallelogram is basically a quadrilateral. A quadrilateral is a 4-sided polygon. And in parallelograms, both pairs of opposite sides are parallel. Well, what do we mean by opposite sides? Well, opposite sides are sides that do not share a vertex. So in this example down here, BC and AD would be opposite sides. AB and CD would also be opposite sides. They don't share a vertex. Opposite angles don't share a side. So A and C would be opposite angles, and likewise angle B and angle D would be opposite angles. They do not share a side. And a little bit of notation for you down here in the bottom paragraph. To abbreviate the word parallelogram whenever we're talking about a parallelogram, if we just draw a picture basically of a slanted rectangle, that means parallelogram. And if it's plural, you just put the letter S inside the symbol. All right. So let's go ahead and move on. Our first theorem says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. That means AB is congruent to CD and BC is congruent to AD. So another property that you will find useful are the angles of a polygon that share a side are called consecutive angles. So consecutive angles are sides of a polygon that share a side. They have a side in common. So A and B would be consecutive angles. B and C, C and D and A are all called consecutive angles. They're next to each other and they have a common side. And from consecutive angles we get another theorem, 6.4. If a quadrilateral is a parallelogram, then the consecutive sides are supplementary. So supplementary sides. So we know that AB plus BC is 180. The measure of angle A plus the measure of angle B is 180. B plus C is 180. C plus D and D plus A. They're all supplementary angles if they're next to each other. And we actually used this when we learned about same side interior angles. We said we're supplementary. So that's actually a specific case of this theorem. Using consecutive angles, what's the measure of angle P in this parallelogram given right here? Well, what we can do is we can say that the measure of angle P plus the measure of angle S adds to 180 from our consecutive angles theorem. And substitute in 64 for angle S, leaving angle P 116. So what happens if we change angle S to 86 degrees? Can we find the measure of angle R in this same parallelogram? Well, yes, we can. What we would do in that case is we're going to set up a very similar equation. We're going to say the measure of angle R plus the measure of angle S is equal to 180. And then substituting in for the measure of angle S, we're going to put in 86 degrees, and that's equal to 180. And we still have the measure of angle R in there. So if we subtract 86 from both sides, we get the measure of angle R is equal to, what does that turn out to be, 94? Does that sound right? 94, let's see, that gives us 180. Yep, that looks like it's right. So the measure of angle R would be 94 degrees. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Another theorem for you. So that says that angle C and angle A would be equal in measure, and likewise angle B and D would be equal in measure. They are congruent if they're opposite angles in a parallelogram. So here's a problem where we're doing a proof. We're given a parallelogram ABCD. We want to prove that those opposite angles A and C and B and D are congruent. So we're going to start off. ABCD is a parallelogram, that's given. So we know that angle A and B are consecutive angles. A and B are consecutive, they're next to each other. Likewise, B and C and D are all consecutive angles, and that's just the definition of what a consecutive angle is. So if we have consecutive angles, we know that they're supplementary as well. So A and B and C and D would all be supplementary. And that is the consecutive angles are supplementary. Okay, that's a definition of consecutive angles. So if we know that they're supplementary, then we know that they're congruent. Now this one I'm going to actually write out something that I think will help you a little bit in this next step. If we say A and B are supplementary, we're saying angle A plus angle B equals 180. But we're also saying angle B, in the middle one, angle B plus angle C equals 180. And we're also saying angle C plus angle D equals 180. Well, if you look at this, it seems obvious that if A and B are 180 and B and C are 180, then A and C will be 180, right? So we can almost say that they're congruent. So we know A and C have to be congruent because they're supplementary to the same angle, so they must be the same. And that's exactly what our reasoning is for that. Okay, so let me just erase that a little bit. And so our reasoning for that, angle A is congruent to angle C because it's a supplement of the same angle, and it's the same for B and D. So here's one where you can do on your own. I want you to pause the video and try this one on your own. I will give you the solution after you try it. I'll just set it up for you before you pause the video. In this diagram we have a parallelogram ABCD. Okay, so we have a parallelogram right here. And we know that AK is congruent to MK. And we want to prove, I'm going to just draw a little dot in here. We want to prove that this angle right here, angle BCD, is congruent to angle CMD right there. So that's what you're trying to prove, that those two angles are congruent. Go ahead and pause the video, see if you can figure that out, and I'll work through the solution with you when you come back. Alright, I hope you had a chance to try that on your own. Let's go ahead and set this up. First we're given that ABCD is a parallelogram, okay, and we're given that AK and MK are congruent. Well, first of all, AK is congruent to MK, and that is a given, okay, so that would be your reasoning. Then you could also say that the measure of angle, I guess I'll call it angle A. Is that what I want to call that? Angle A is congruent to angle, and I'm going to call it what they call it in the figure, angle BCD. I'm going to label it the same way. It's not a very good B. Let me erase that B so you can see it a little more clearly. Angle BCD. Okay. Why would those two angles be congruent? This one right here is congruent to this one. And that's because those are opposite angles in a parallelogram. So you could just say opposite angles in a parallelogram. So go ahead and draw your little parallelogram symbol there. Okay. So we've got those two angles being congruent. What else can we say? Well, we could say that angle A is congruent to angle, and I'm going to label this one the same too, CMD. CMD. Why in the world would those two angles be congruent? Why would this angle over here also be equal to this angle over here? Well, that has to do with this AK being congruent to MK. If AK and MK are congruent, that means that triangle AKM is an isosceles triangle, and so that would be an isosceles triangle theorem. Isosceles triangle theorem. I'm going to abbreviate that one for you. So we're just about home free here. We have angle A is congruent to two things, right? And so since these two angles are congruent to the same angle, we can say angle BCD is congruent to angle CMD by the transitive property. Or you could say substitution would also work. Two things equal to the same thing are equal to each other. And that was what we were trying to prove. Here is your lesson check. You've got 6 problems this time. Go ahead and work on those on your own and bring your answers to class. And we will see you next time.